Welcome to this whiteboard session on backup strategies, pros and cons. This is a technical session, so we're going to do 50% whiteboard and 50% demo. And we're going to start off with how best to read the data, so how best to deploy proxies and agents to read that data, and also look at storage integration in terms of VMware and Hyper-V. We're then going to look at short to medium term retention, how best to store that data and options around repositories. And we're then going to look at how best to move that data for long-term retention, so tape, DGIP appliances, and our scale-out repository and our cloud tier. Along the way, we're also going to touch on some of the things, features and functionality coming in the next version 10 of Veeam Backup and Replication. And we've also got our colleague Nikolai on the chat window if you want to pose any questions along the way. If you are watching live, we really appreciate the time you've taken out of your day to watch this, and we hope you benefit from some of this information and you can take it back to your own environment. So with all that being said, let's move to Jorge on the whiteboard and let's talk about how best to read the data.
Thank you, Alex. Let's start with VMware, how we can take the information from a VMware environment, because we have different ways. So the first way, as you can see here on the environment, we have the hypervisor over here. Then we have, imagine that there are a couple of ESXis, and then we have the storage there, like it can be the Dell EMC, it can be HP, for example, and so on. Our integration list is quite huge. So we can take the information in a different ways. Let's start, for example, with the hot add. Hot add, it's based on a proxy that we deploy as a virtual machine inside the environment itself. And that can be Windows today, or it can be as well Windows, or it can be as well Linux starting in version 10. So that's a new functionality, and that will allow, for example, on deployments like a vSAN, for example, or in remote branch offices, to have much less cost of the overall solution itself. So the hot add, what it's going to do, because it's inside the environment itself, is going just to mount the disk, and from there is going to take the information out, so read it from the source, and then send it to the backup repository themselves. So that is the hot add mode. Then the next one that we can discuss is network mode, which is nothing difficult, it's nothing fancy. We just take the information directly over the management network. The network mode, it usually works much better in a 10 gigabit Ethernet connectivity. So I'll recommend it to you to try network mode if you have 10 gigabit. So network mode, it will be directly from the, let's think that it's going to go directly from the hypervisor directly to the backup repository itself. And then the other transport mode that we have, it's what we call direct SAN or direct NFS. And for that, we tend to recommend, of course, just to dedicate a physical proxy. That physical proxy, for now, it needs to be Windows, but in the future, Linux is going to be integrated the direct SAN mode and the storage integration. But for now, today, that needs to be a Windows server, physical server, which it can has the connectivity to your VMware environment as a 10 gigabit Ethernet or fiber channel, imagine. So what this does is just talks directly with the storage itself, and then from here it just processes the information and it's sending to the backup repository itself. Benefits of having direct SAN with a dedicated Windows proxy. As you can imagine, it's much faster. It doesn't stress at all the VMware environment, because it's just grabbing the information directly from the storage arrays, which they are built for these purposes at the end. And another really cool thing doing with the storage integration is that you can retrieve the information from the SAN directly, and you can trigger the API of that specific vendor to do different things. For example, storage snapshots. So here we can just trigger snapshots, as many snapshots as we want, directly from the Veeam console itself. And from these storage snapshots on the storage array, we can take the information from there, or we can read that storage snapshot to later on restore as an instant Veeam recovery, or we can do as well, we can do just orchestration of the snapshots from this array, imagine, to another array that it can be on the secondary place, on the secondary location, and we can do so many things with the storage integration. We tend to recommend for the enterprises or for a high business, For a high commercial business, we tend to recommend the storage integration. It is much better, especially if you have HP, Dell EMC, Pure Storage, a lot of integrations that we have with. So that is VMware covering all the transport modes plus the storage integration, which we tend to recommend it as well for to add it as a part of your backup strategy itself, because you can retrieve the information much quicker and trigger more snapshots with less stress. Next, let's talk about Hyper-V. Hyper-V, we have a deep integration with Hyper-V, no problem at all. If you just install Veeam pointing to a Hyper-V environment, we will tend to use what we call the proxy on host, and that's really directly from the every Hyper-V host itself. We just tend to send information directly from there back to the backup repositories. It's kind of like what we can call hot but on Hyper-V is called on host. So directly from every Hyper-V, we just take the information of the VMs, take the snapshot, and then directly send it back to the backup repository. If you want something more dedicated to the stress much less the whole Hyper-Vs, which are serving you production itself, you can just dedicate one Hyper-V, which it has access to the SAN where all the Hyper-Vs are running the VMs, and then you can just directly from there just take it what we call off host. So that is called off host, and this is called on host, and you can just combine them. Absolutely, what you want to do. Let's move now to Acropolis. We do have support for AHV, the Nutanix hypervisor. And for Acropolis, what we do is we use another appliance that we deploy. Today, you need to deploy it manually on your AHV cluster. But starting in V10, you will be able to deploy this appliance directly from the VBR console. What we do, we just install just one OVA appliance on the AHV. That's the recommendation from Nutanix. So we just work really close with them to follow the best practices to do all of this. And with this appliance, it's the proxy itself, and it has as well the management console that you can access and create the backup jobs directly from the snapshots on the Nutanix, and so on. It's really efficient, and the GUI of this AHV, it really reminds you, the customer, really reminds what Prism has for Nutanix. So it's really based on that modern, fresh HTML5. So directly from here, what we do is we just take the information from here, and then we send it from this proxy / OVA appliance directly back to the backup repositories. Now we just cover the three main hypervisors integration that we have. Let's talk about let's talk about agents itself. So the agents, every agent itself, we like to call it that is their own data source, their own proxy itself, because it's just process the whole data before send it to the backup repository, of course. So we do have different agents. We have an agent for Windows that you can install, for example, on physical servers. You can install those Windows agents on a VMs that they are on a cloud that you don't have access to the hypervisor behind. You can install it, we recommend to install it, or for example, on VMs that are running failover clusters, like SQL always on, Exchange. If you have a file server failover cluster, we tend to recommend to install the Windows agent anyways. So we have a Linux agent, which I'm absolutely a Linux lover, so I really like the Linux agent itself, because you can just take whatever you have on the cloud, Nginx, MySQL, Apache, everything, and then you can just protect that as if it was a VM. So that's really powerful. Then we have for the agents, we have the Solaris and AX agents as well. So and then we have what we call plugins, which we have a plugin for Oracle Arman, and then we have another plugin for your SAP HANA, meaning that those specific applications, we retrieve the information from those applications, and then we send it everything to as you can imagine, to the backup repositories as well. And then what we will introduce in V10 as well, it's the support for the filer itself. If you have a NetApp filer or an EMC, or even any SIFs or NFS with billions of files or thousands of millions of files, then we will have support for that to retrieve that using what we will call file proxies. And then these file proxies, you can deploy as many as you want, same as here with the physicals or with the hot. That's really important, that you can always scale the proxies as much information as you have. So we will never charge per any of these just to help you to scale. And that's the file proxy. And as you can imagine, we will just take directly the information from there and then send it back to the backup repositories, as you can imagine. So with this, we cover the whole source of what we can take today from the different sources. And I think with this, maybe it's much better now that we jump into the console and we see it with your own eyes.
Thanks, Jorge. Yes, so proxies are the heavy lifters, the workhorse, if you will, of the Veeam backup and replication environment. So not only do they take data from source and send it to the disk repository, the target, but they also need an element of compute to do the processing of dedupe and compression. So there's a lot that these proxies do, and it's quite important to understand that with Veeam, there's no real licensable limit on the number of proxies you can deploy and or repositories. Now that does change somewhat when we talk about scale-out repositories later, because there is a licensable limit there. But if you need more read load, add more proxies. If you need more write load, add more repositories. In small environments, you might have the same coexisting on the one server for really small environments. But if you're an enterprise customer or you need to scale out, then you can just deploy these where you need them to manage your read and write load. So let's jump to the console and start have a look at how you deploy these. Now, the first thing you'll notice is this is not the Veeam Backup and Replication console. This is actually our Veeam 1 monitor console. And the reason I'm showing you this first is because I want to talk about concurrent tasks, different transport modes, and this is a great visual aid to be able to look at how many concurrent tasks and what's going on within the environment. It provides that what we refer to as complete visibility. So if you look in the monitor console, you can see that in this lab environment, we're doing hot-add, which is the virtual proxies for VMware. This is the VMware view. And we're also doing some network backups, but we're not doing any direct SAN backups. It gives you some information here. And you can also drill down and have a look at the hosts themselves and how many concurrent tasks they have. Concurrent tasks is a very important thing because it really dictates how many virtual disks this proxy is going to be able to process at the same time. Now, the second part of Veeam 1 is the reporter window with the dashboards. And for me, this is a very useful, this option, heat maps, is a very useful tool to be able to troubleshoot and have a look at how the environment's doing in both read and write, and also utilization of the repositories. So I'll just give this a moment to load, but ultimately what this will show you is a nice way to have a quick look. Now, this is live, so this normally loads a lot quicker than this, so if it doesn't load, I will probably just skip on and go through proxy deployment. But heat maps, what it shows you is it's like a traffic light system, right? So it's green, amber, red. How are the proxies doing and repositories doing during these hours of the day? But it also shows you the number of concurrent tasks. And it's really important to understand that if I have 10 concurrent tasks through my proxies at the front end, but my repository only has 4 concurrent tasks, well, I'm only going to be able to process 4 virtual disks at the same time. So it's a balancing act, if you will, between proxies and repositories. It might be that your scheduling is such a way that doesn't matter, or you just process down through. But if you use heat maps, it will let you know if there's any issues, if you need to deploy more proxies and or more repositories. Right, so let's jump to the main VBR console. Okay, so we're going to run down through the list that Jorge did on the board there. Going to start off with VMware. So I've got 2 VMware proxies here. These are both virtual proxies. But ultimately, when you want to add a new proxy, you would right-click here or right-click on proxies on the left-hand side, and you add a new VMware proxy. Now, when we go through this wizard, we first give a DNS name, preferably a DNS name for the server we want to deploy this transport role onto. It could be physical, it could be or virtual, depending on what mode, transport mode you're looking to utilize. In my case, in this lab environment, they're all virtual proxies, but it might be that you want to do SAN-based backups as well. So first you give it a name. You put the DNS name in, you then choose what the transport role will be for this proxy. So we have 3 main modes, as Jorge explained. We have direct SAN mode. So if you're not doing storage integration with primary arrays, then this is just direct SAN backup. And there is no license to do direct SAN access backup. Now it's good for throughput for those big, large file servers, maybe database servers, but you don't need to put everything over the one network, right? So it might be that that's dedicated to those larger servers. Then we have virtual appliance mode, what we refer to as hot add. So this is a virtual proxy running on the hypervisor, and you may have more than one. In fact, one of the reasons why you might use a virtual appliance is because you have a hyper-converged environment. So you might have more than one. You might actually have a virtual appliance per host. So you can find that target VMDK disk, attach it locally to that proxy over the I/O stack of the hypervisor, and then send that data to the disk target. And then the third option is network mode. Now, quite often, unless you've got a 10 gig management network, this is used as a failover mode for direct SAN and virtual appliance. But again, if you do have a 10 gig Ethernet, then it can actually get decent speeds across the network. So it might be that network and virtual appliance are used for those smaller, those domain controllers or web servers that maybe you don't need that throughput of a direct storage access. But you can let the system decide, or you can manually specify which transport role this proxy will do. So obviously, if you're doing direct SAN, then it's likely to be a physical server attached to a fiber channel network as an example. But we also have storage integration, which I'll come on to after I've finished off the deployment of this proxy. If you are doing SAN-based backups, you would present the VMFS data stores. If you're doing storage integration, then we would orchestrate that process. But you can choose the data stores you want to read from. And then the concurrent tasks is probably the most important part here for me of a proxy deployment, because this is really governed by how much CPU or RAM you have in this box. So generally, virtual proxies have less compute. So in this case, if I try and increase that number of concurrent tasks, you'll notice we're going to get a warning from the system to say we don't have enough CPU to be able to process 3 tasks. We have to leave it to 2. So in terms of virtual, you'll probably have more virtual proxies than you would in a physical, because physical is likely to have more compute, and maybe you can do 20 tasks, or as an example. So that's how easy it would be to deploy a proxy. We'd go out and install that, and then in the backup job, you would specify manual selection proxies or automatic. In terms of storage integration, like I said, if you've got a proxy attached to the storage network and you want to integrate with the snapshot and replication and orchestrating snapshot creation on a primary storage device, then you would come into this section of the UI. Here we've got a HP Store Virtual registered, but if you want to add a storage device, here, this will provide a list of all the storage vendors that we integrate with. Everyone has slightly different capabilities. All of them will do backup from storage snapshots. So this allows us to create the VMware snapshot and almost immediately release it at the hypervisor level. So there's no build-up of snapshot change in VMware. There's no commit process at the end. We simply present the storage snapshot up to a proxy and do a backup. And at the end of the backup, we either delete that snapshot or we keep it on the array as an added restore point. What I very often refer to as a get-out-of-jail-free card. It's also good to use for testing. So if you want to do some SQL testing using our data labs, then maybe you'll present that from a storage snapshot with production-like performance as opposed to doing it from a backup. So we've got Cisco, Dell EMC, HP, IBM, NetApp, and then we also have some additional plugins for other vendors. So we have our universal API now, so vendors have the ability to write their own plugins. So as you can see here, we also support the EMC SC series, Fujitsu, Huawei, Infinidap, Pure Storage, and Western Digital IntelliFlash. Once you log into these storage arrays, it's worth noting that we will expect that you want to do storage backups or backup from storage snapshots. So if your proxy is not attached to a storage network, then the backup jobs may fail unless you change the default to not attempt to do storage backup from storage snapshots. You can go to our website to see what capabilities each vendor has. Okay, so moving on to Hyper-V. Again, VMware is very easy in terms of deployment, but every hypervisor is slightly different. So in terms of Hyper-V, the first thing I'm going to show you is that when, as Jorge explained, when you log into your Hyper-V environment, then we automatically put our data mover onto the Hyper-V host running your VMs. So in my case, I've just got a single Hyper-V host here, and if I go to Properties, you'll notice that we can register, go back one, we can register a virtual machine manager, a cluster, or a standalone host. In my case, it's a standalone host. But if I go to the apply option here, this is where the concurrent tasks are at an on-host proxy level. So the default is 4. Notice that when you increase this, it doesn't warn you like it does in VMware, so be careful about increasing this number. Generally leave it default or maybe lower it if you don't need that many concurrent tasks. And the benefit here is there's no additional infrastructure required. We don't need to deploy a physical server. You just need spare compute on your hypervisor host to be able to process the backups. And it's a very easy option for many of our customers. If you don't want to put that extra load on the Hyper-V host, you can, as Jorge explained, deploy a off-host proxy. Now, an off-host proxy is very much like a VMware SAN-based backup. It's effectively a physical server that has the Hyper-V role. This allows us access to the shared storage, so it means that we can effectively do SAN-based backups and also leverage the hardware VSS capabilities of the array. So use hardware VSS when we're doing those backups directly from that SAN. Just like a virtual proxy, when you deploy it, you can specify what volumes we're going to do that read from and how many concurrent tasks we're going to be able to achieve, and the same thing applies in terms of CPU resources. So there's only two options with Hyper-V, on host or off host, whereas there's three options in terms of VMware deployment. AHV is slightly different. With AHV, we would deploy an appliance, and that appliance is a single appliance per AHV cluster. So it's very much like a virtual VMware proxy in terms of deployment, but also slight difference with that environment is that it's also where you manage and create your backup jobs. So recovery operations and the data is stored in backup and replication, but the actual management of your AHV environment is done here in the actual proxy itself. That's where you create your backup jobs, and then you can recover from the VBR console or recover from here. So very slight difference, and you have one virtual appliance per cluster. So not much to say on that in terms of compared to the other hypervisors. Okay, so going back to the main console, the last one is agents. So if you want to deploy any physical agents, and this will potentially include virtual machines that maybe have RDMs or aren't 100% virtual, then what you would do is you would create a protection group, or you can individually deploy the agent if you wish. And you can choose if you want to deploy the agent based on individual DNS, whether you want to do Active Directory deployment, or whether you want to do CSV and a whole group of servers. Reasons why you choose Active Directory? Well, maybe you're rolling this out as a policy for laptops, or if you're doing server-based backups, maybe you want to be cluster aware, so you're choosing the cluster instance through Active Directory, and therefore we identify the cluster nodes and deploy our agent. So there's many reasons why you would use this, but it's important to note that they are effectively their own proxies. So if you're going to be sending 10 physical backups to a repository, keep in mind that it's going to consume those repository concurrent tasks. And if you're sharing it with something else, then it might be that some things are going to pend and wait for concurrent tasks to be available. So you can have as many repositories as you want. You don't necessarily have to have one. So you might have one repository for agents, one repository for virtual, or maybe you just want to classify your workloads into different repositories. So just keep that in mind. Once you've deployed the agent, you can then create your backup jobs, and you can process multiple physical servers just like you would with virtual in one job. So lastly, before we go back to Jorge on the whiteboard, what I want to also just show you is the stuff we talked about in version 10. So version 10 is going to add some additional functionality, the first one being NAS backup, so the ability to back up files, not have to necessarily deploy an agent to back up the operating system, but just back up files, whether it be a Windows file share server or a NAS device with unstructured data, so just a straight UNC path. A file proxy, when you deploy a file proxy, it is responsible for reading that data just like any other proxy, and you can deploy as many file proxies as you need to balance that workload out. And when you register the file share, you can also use things like, if it's a Windows server, you can do VSS on that Windows server to get access to locked files. Otherwise, we might skip those files, but that would be a new option in version 10 for our NAS backup. So for anyone who has, say, a NetApp, for example, a lot of unstructured file data, then we have the solution in the next version for that. And also, for people who don't necessarily want to use a Windows proxy in VMware, now you can utilize existing servers that might be underutilized, and maybe you want it to become a data mover in the evening. However, there is license involved with deploying Windows proxies. We now have this option to deploy a Linux proxy. Now, it is limited to virtual appliance mode only in version 1 or in version 10 when that gets released. Maybe we'll open it up to SAN-based backups and network later, but it's a virtual appliance doing hot add mode. But it just means that you don't necessarily have those additional license costs of deploying Windows proxies. So the last thing to say is also that we have the notion of proxy infinity rules. So when you are looking at a repository, you have the ability to dedicate certain proxies to just use certain repositories. It's a nice way of segregating data for whatever reason, but it's something that we probably don't talk about enough at Veeam. So that's proxy deployment. They're a very important part of your infrastructure for reading the data, although we do synthetic backups and incremental forever, so we do try and minimize the amount of data we need to read after that first full. But we're now going to move on to short and medium term attention and options around repositories. So let's cut back to Jorge on the whiteboard, who's going to cover that off.
Thank you, Alex. Well, as Alex said, we are going to cover now the targets, so meaning the backup repositories itself. I'm going to go starting from less to more. So let's start with, for example, with just commodity servers. Imagine that you have just some commodity servers with tons of storage inside those servers. Or if you just have, for example, imagine a NetApp series attached to a server. Or if you can have just some HP MSA and then connected to some as well HPDL, for example. Just let's talk about kind of direct storage itself, direct attached storage. So we do have today we have Windows, so direct attached into the Windows, and then we can leverage the REFS format of the Windows itself. Meaning that we will be able to take the synthetic backups over the weekend much better, because we will use the fast cloning to merge all the blocks itself. That's with Windows. The news about coming in V10 is that we will leverage as well. We can use Linux as well as a backup repository. We can today use as a backup repository, but we will start leveraging as well what we call the XFS. Well, what Linux technology XFS, the file system, meaning that we will be able to use block cloning technology on XFS, which is new in V10, and which will allow you to create the synthetic full backups and do the merge of the backups chains much faster on a Linux environment. Why will you do that? Why will you have like a Windows or some Linux? Well, as per usual, we tend to say if you want to have more security, we tend to recommend to have different backup repositories, just that in case that a ransomware hits the Windows server, at least you have some copy as well into the Linux backup repository. But we have some protection as well coming new in V10 for all the ransomware thing. But we will cover that on that later on. Imagine that instead of having direct attached disks, you have some big appliances, some NetApp, some QNAPs, or some Synologies, for example, or some really enterprise things like NetApps, and you just want to leverage CIFS or NFS, which is much easier. You don't need to configure anything like a REFS or XFS, because it's too complex, and you just want to throw the backups into like a CIFS share, a big CIFS share or a big NFS share. So we do have integration for that as well. And then CIFS it is today. NFS today, you just go through the Linux server itself, and then you see the mount path. What we will have in V10 is direct access to the NFS as a target, so we will be able to save the backup repositories in any NFS directly without going through any Linux host or anything. So that's new in V10, quite exciting. As I said, I'm a really Linux fan, so I really like that now we can send the backups into NFS. Now, for the last set of targets that we have, more enterprise ready. That's what we tend to say. I cover the London area, and I tend to see a lot of the dupe appliances. So we have integration today with Data Domain. We have integration with Exagrids, with HP StoreOnes, and Quantum DXI. So what we do is we have a deep integration with all of these vendors, so they ingest our backups in a really, really fast way. And then what they do is they understand all our blocks and they just do the dupe and compression. And I've seen the dupe ratios like 95% or something like that in some of these vendors. So it's absolutely great. Another benefit of using the dedupe appliances is that they usually have a kind of replication between them, between sites. So that's really powerful to leverage those technologies on those arrays itself, just to replicate between sites. And last as well that I want to mention is that we just communicate to them through a specific API that every vendor exposed to us. So that allows us as well to, when you have all of this, one of these vendors, it's more secure because no one, no other user can access these shares themselves because we are just talking directly through an API. So that those integrations, these enterprise integrations, they are much securer and much more efficient. And then coming in V10, I just wanted to mention that we will have HP Store One's Catalyst copy support. So that's going to leverage one of the big functionalities of the HP Store Ones, which is replicate between the HP Store Ones themselves. So we will be able to see that into the Veeam console. We will have support for that. So these are all the targets, the different targets that we do support. As you can see, a lot of them. We can combine those on a scale-out backup repository. We will cover the scale-out backup repository on the next section. So for now, I think that now is the turn of Alex to show all of these target backup repositories on the console.
Great, thanks, Jorge. I believe we might have had some streaming issues, so hopefully we're back up now live. And if you are watching live, this will be recorded and put on demand on our website. So you can always watch the bit you may have missed later, so don't worry about that. So yeah, let's move to the console and let's talk about repository deployment. So in the console here is where you would deploy your repositories. You can see I've already got some registered and I'll go through those in a moment. So if you right click in the space, or again, just like proxies, you can right click up here, you can add a new repository. Again, there's no limit unless we're talking about scale out repositories where you do require an enterprise or above license. We're going to come on to that in a bit more detail in the next section. You have all these options. Now, firstly, I'll talk about object storage. Object storage cannot be used as a primary target for your backups. In backup and replication, it is a tier that you can use. So moving those older backup files, and in version 10, copying all backup files. We've just announced this week in our backup for Office 365 version 4 that's just gone general release this week that you can actually use object storage as a primary target for backups in that platform, and we will hold metadata on the server so we don't consume more expensive disk. So if you are an Office 365 backup user, then you can go and have a look at that today. So we'll look at direct attached storage. As Jorge mentioned, we are looking in version 10 to add fast clone, so similar to the way in which we leverage REFS in Windows today with Linux in version 10. So if your preference is a Linux operating system, you will get some benefits in terms of disk utilization, not only in consumption, but also the performance required because we're not having to read and write back the data. And I'm just going to use this slide quick example to explain what we mean by that. So for NTFS today, so we're thinking Windows 2012 or below, because REFS, the version of REFS on Windows today needs to be 2016 or above. There is a version in 2012, but that is not supported because it's sort of version 1. So on a 2012 repository or below, you're looking at NTFS, or maybe you've got a NAS repository. The way in which we do our incremental and synthetic backups is very good from a production perspective because we write the backup. So this backup file that's on the Veeam repository could be a single server, or it could be a group of servers in a backup job that are deduped and compressed down into that file on disk, which we refer to as a VBK file. And then we create our daily change. Again, that could be one server or a number of servers. They're changed into what we call a VIB file. This is just one of the ways in which we can hold data. But when we come to do our synthetic, rather than having to go back to production and do a full backup, which we can do, called an active full if you want to do it, but you don't necessarily have to do it every week. You could do it once a month, once a quarter, whenever you feel that you want to get a fresh backup. What we do is we do an incremental from production, finish the backup job, and then we read all the data we have on that disk device to create a full backup file. Now, if this full backup file is 2 terabytes in size, then we need 2 terabytes of space to be able to accommodate that new full. although we have removed the load from production, we've now put it onto the backup estate. And it also means we need the time it takes to read and write back that data. So it's a great way of offloading from production, but still puts some stress onto the Veeam backup and replication environment. So this is commodity storage block storage on a Windows server and soon to be Linux. With REFS, it's slightly different. Exactly the same scenario, but this time what we do is we do the incremental, the daily change, and then we put metadata pointers within the file system to the existing blocks that we have stored, meaning that it may look like a full backup file, but actually what we've done is just put metadata updates, so we haven't had to process the entire amount of data. We've just stored the unique change, so from a consumption perspective, we don't need the space of a full backup, we just need the space for the daily change, and it happens in minutes rather than hours. So in my demo lab, as an example, a 200 gig backup file took about 4 hours to process on a slow SATA drive. When I moved it to REFS, it went from 200 gig consumed and 4 hours to process to 200 gig to 2 gig consumed and 8 minutes to process the full. So it's a kind of win scenario. It's no additional license from Veeam. It just means that you just have to have the Windows licensing or the Linux licensing to be able to utilize this technology. So just wanted to explain the benefits around REFS and how it can really help you with synthetic backup times and your retention you can hold on that commodity storage. The second option in the list is network, and as we said, this is a NAS device, so today it SIFs, but as you see here, we're looking to add NFS repositories. Now, they will obviously consume more space over time, but the great thing about a NAS device is it generally has a huge amount of capacity. So, you know, again, there's nothing wrong with using NAS devices. It just means that you're not going to get those space efficiencies that we get from REFS or XFS on Linux. But again, just a great target, maybe good for short-term retention. And then maybe you'll do a backup copy to a secondary target somewhere, which is what we're going to cover in the next section. Third option in the list is dedupe appliances. So there are four main vendors that we work with. Dell Data Domain, Exagrid, HP Store Once, and Quantum DXi. So the great thing about these devices is probably more to do with long-term retention. So you can use them as a primary target for your backups, but we quite often say your primary backup doesn't need to have long-term retention. You can do a backup copy or maybe utilize objects in version 10 that we're about to talk about to service that long-term requirement. They'll always dedupe to a lower level than we would do in software, and it also takes a lot of that processing away from the Veeam environment, and we sort of offload that synthetic backup process and that dedupe and compression capability to these arrays. So you just need an enterprise license to be able to leverage one of these arrays, and they can be really useful for that long-term retention, especially if you don't want to send your data out to cloud for any reason. So that really, just checking my notes, yeah, that really covers the disk repositories. And I'm just going to reinforce the fact that your primary disk repository for your backups doesn't have to service your long-term retention, as we'll show in the examples at the end of this session. However, it's going to change somewhat in version 10, where we add the ability to do GFS on primary backup jobs and the ability to copy all of your backups into object storage, not just your older files. So really helping you achieve the 3-2-1 rule with Veeam. So let's move back to Jorge, and we're going to cover longer term retention, primarily scaling out repositories in our cloud tier.
Thank you, Alex. Let's cover now scale-out backup repositories. The benefits of using scale-out backup repositories is that you can combine any of these backup repositories that we just covered on the previous section. So you can just combine some REFS with some Linux, with some SIFs or NFS, with some dedupe. So that is perfectly fine because you can just scale as much as you want, just keep adding extents, which is going to be any backup repository that we just seen. We extend the scale-out backup repositories with what we call capacity tier, cloud tier. We did cover this with another session that we did with Alex, so you can just take a look into into the previous videos, because we did cover that in advance with the blocks, how they move and everything. So we can extend the scale-out backup repository to any object storage on the market. So we covered today S3, EWS S3. We have integration with Azure Blob. We have integration with IBM Cloud. cloud, and with any S3 compatible that it's really up to date within the API. What all of this means at the end for you? Well, it means that we tend to recommend to send backup copies to another site, to a secondary site, or if you have some of the dupe appliances, just to leverage the replication itself. We do tend to recommend, imagine that this scale-out backup repository is in your secondary site, for example, and then what we do have today with the capacity tier, it's that what we can just move data, closed chains. We can move them to an object storage. That's what we can do today with the capacity tier. So let's think that this long-term retention, for example, this long-term retention, because it's your weeklies, your monthlies, the yearlies, so the GFS itself, this today can be offloaded or moved to the object storage, right? And is going to save you a lot of space in disk, and is going to kind of replace tape, for example, for the cases that you want to replace, you're looking to replace tape. This is a great advantage just to leverage what we have, the capacity tier to object storage. That's what we have today. That's what we could move, offload. In V10, we are stepping up our game with the moving what we call copy, meaning that every single point in time, every single point in time can just be copy, have an exact copy of that into the object storage. What's the benefit of this? Well, it's pretty obvious that at the end we have the 3-to-1 rule. Now we have a copy on the repositories, local repositories. Then we have a copy, an exact copy on any of these S3 in any of these object storage providers. And of course, it's just giving us a lot of confidence that if we just lose the primary site, or we get hit by a ransomware, as I said, on the primary site, and it encrypts absolutely everything, even REFS, XFS, everything. At the end, you have an exact copy of that daily into any of these object storage. This is perfect as well for the forever incremental that sometimes you might have on some of the servers or workstations, for example. This is perfect because any single full incremental anything is going to be an exact copy on object storage. And talking about that as well, let me pick this other color, because now we will introduce as well, if this wasn't enough, protection, which I think it's quite comprehensive. Now we are going to introduce as well what we call immutability for the object storage. So I'm going to draw here a small locker over here. So what immutability means is that any of these, so even the move or the copy, either of them, you can just make them immutable. For example, make them immutable for 90 days, 2 years, 3 years, whatever it's important for your business. And even if you get hit by a ransomware, encrypts absolutely everything, and it tries go through an API to the object storage, or even if it's like a malicious activity as an ex-employee trying to delete the backups. They will not be able to do that because we have the immutable enabled, and it cannot be deleted from the bucket itself. So as you can see, the scale-out backup repository, it is much more than just an agglutination of backup repositories itself. It's really a way to offload data to the cloud. It is a way to copy data into the object storage. And now with the immutability as well, is going to give you the security that nothing is going to be deleted from any of these sources. So I think with this, as per usual, I think I did cover it with drawing. Let's move to Alex, so he will show us on the demo.
Great, thanks, Jorge. Yeah. So we're going to talk about cloud tier in our scale-out repository. It's not the only option for your long-term retention. We still support tape, or you could use a dedicated dedupe appliance that may be able to extend that retention for you if you don't want to send data into the cloud. The issue around tape, for example, is that the fact you have to manage backup jobs, tape jobs. There is a schedule, there is a job to manage, there is time it takes to get that data to that device. And there's still a great air gap solution for things like protecting against ransomware. However, as Jorge has explained, with immutability, that means that you can achieve the same thing by sending data out to object storage, whether it be on-prem or whether it be in a cloud provider. And it really because there's no job to manage, it's an automated tiering process. It means that the system just moves data and carves data up, and just like REFS, we hold metadata as we covered in our previous session. If you look back through the Veeam Live videos, we hold metadata either side for object storage. So we're being clever about consumption in that object storage platform, as well as egress charges in terms of recovery as well. So let's have a look at the console and see how you deploy a scale-out repository and leverage the cloud tier. So the first thing to say is scale-out repository isn't new. We've had it for a number of years. What's new is what's new in the last year or so is the capacity tier, the ability to offload to object. And as Jorge has explained, we're enhancing this in V10, and I'm going to show you the difference now between 9.5 today and version 10. So to create a scale-out repository, you need first a normal repository on-prem, so which is going to be your performance tier. Or capacity in terms of data locality. It is a normal repository, but it has to be empty when you add it into a scale-out repository, so you can't take an existing repository and promote it into a scale-out repository. But what scale-out repository does provide is the ability, not only, as it suggests, to scale, add more devices in when you need to scale. It's a single target. This would be the target for your backups, and all the devices in it are pulled together. And then the system will distribute data based on your placement policy on-prem and allow you the ability to put devices in and pull devices out as you want to decommission them. So you would first have to have at least one device in your performance tier and decide whether you want that to be placed based on locality or performance. So whether we're going to distribute fulls and incrementals onto different, as we refer to, extents, so different repositories, or whether we want to place those files together. And this is the tiering option. So you can log into your object storage prior to running through this wizard, but you can do it here as well. So that's what I've done as part of this demonstration. And we have covered the ins and outs of this in the previous session, as I explained. So firstly, you would enable this capacity tier and you would add in your object storage. Now, it could be an S3 capable device, so that includes on-prem devices as well as third-party providers such as Wasabi, one of our alliance partners that provide cheap object storage. It could be Amazon S3, it could be Azure Blob, or it could be IBM Cloud. So they're the kind of main devices, but S3 encompasses a number of different providers, third-party providers that you can use for your object storage requirement. Once you've logged in and you've created your bucket and your folders, you effectively then have a few options here. So this is 9.5 as it is today, the move option. So this basically says that over a certain period, any files over a certain age that are sealed and not changing anymore, so think GFS files, which is why a lot of our customers will use this for a backup copy target. We're creating fulls, weeklies, monthlies, etc. that are just consuming disk space. So let's get them off-site, let's move them off-site, still have the ability to recover, but not consume that more expensive disk on-prem. So in this case, I have 4 days set. Because of the way in which I'm storing the data, I've actually got a few more days than 4, but I'll show you that in a moment. You also have a window where we do or don't want data to be moved, maybe during certain hours of the day or on certain days we don't want data to be moved. It is an automating tiering process, as I'll show you in a moment. Or maybe we want to override the day setting here by saying, well, if our on-prem devices do start to hit a threshold and they start to fill up, well, let's start moving data early so that we don't run out of disk space on site. So there's a few settings in here, and you can encrypt that data. So everything with Veeam is end-to-end encryption. If you set a password here, then your data in that object storage will be encrypted. So what I want to show you here is quickly what this looks like in terms of the tiering process and recovery. So if I go to the home area and I quickly look at success, what you'll notice is this scale-out repository offload. So this is, as I say, a tiering process. There's no job to manage. We simply look for files, and if I go down through this list, I may be lucky enough to find that we've moved a file. No, I haven't had to move any files in the last 24 hours. And from a recovery perspective, if I was to browse this backup copy job where we're holding GFS retention and I was to browse those backup files, what you'll notice here is we have on-prem files. So this is an incremental and this is a full. So side arrow and downward arrow with this rectangle. It shows that data is on site and you can see it's been labeled a weekly through our GFS schedule. But as I scroll down, you'll notice the icon will change. and we now have full backups that have been shipped off-site to object storage. They only now exist in object, but they can be referenced from, think of it as an extension of your on-prem scale-out repository. So I can always pull data back if I need to for any reason, but ultimately when we come to do any kind of recovery, even instant recovery out of an object storage with cloud tier enabled, we're always going to try and rehydrate from the local blocks first before we try and pull anything back from objects. So it's only unique blocks that are stored in object that will be pulled back. So it's always the ability that we try and minimise the egress charges and charges you've got in that platform. So how this differs in version 10, as I say, is the copy mode. A lot of our customers did point out that this doesn't necessarily achieve the 3-2-1 rule that we at Veeam talk about a lot. So when you look at a scale-out repository here, you'll notice a slight subtle difference. Same options, but when you get to capacity tier, we'll now have this copy option. Now, what copy means is that everything under 7 days, including last night's incremental, is going to be copied. And with the fact that we're adding GFS to primary backup jobs, it could be that you don't want to do a backup copy job to a secondary location. Maybe you only have one data center. And in that case, object becomes your offsite secondary location, and you get a complete copy in object to recover from. So it's a simple case of ticking this box. And then the subtle differences you'll notice is that when you go into the home area of version 10 and you look at your backups, you now have this object storage section. So this is looking at the files as they are offsite in object storage. If I look at this backup job here for this Win1, we have 10 restore points in object. Sorry, that was the wrong backup job. Sorry, this one here. We have 15 for this Win server 2. And we also have the same 15 restore points on site. And when you go to the object storage and you browse the recovery points like I showed you in 9.5, you'll notice that the icons are dual. So we have a rectangle for on-prem data and data copied out into the cloud. So everything that we've backed up on this device is copied into object storage. And that means that if you were to lose that main site, you always have a copy of that data in object storage to recover from, and that may be your offsite location. So that's just covering options around cloud tier and scale out repositories, how you can utilize that and have to get away from managing tape jobs and things like that. So lastly, we're going to take all the things that we've talked about, and I appreciate some people may have missed the start. You can watch this on demand, and we're just going to quickly cover off some scenarios of how you can achieve your short, long-term retention. So let's cut back to Jorge on the whiteboard.
Thank you, Alex. So just to wrap up everything, remember that we just take from the source all the data. We tend to send them. Remember the concurrent tasks that Alex mentioned. That's really important. If you have like 10 proxies over here with multiple concurrent tasks, multiple CPUs, you will need to you would like to have same kind of repository to ingest all that data. Maybe it might be like an enterprise Dedupe appliance, or it might be just a combination of multiple commodity servers, for example, or it might be a combination of all together at the end. But just please bear in mind that the concurrent tasks on the source, or even the agents, which every agent is a concurrent task itself, needs to be reflected as well into the backup repository to avoid any bottleneck, really. And then after we just have the data over here, as Alex said, we can have just one site. If you have one primary site, we recommend it to you either use tape or either start using the new copy option in version 10. Even if you have like a single site as well, start leveraging today the move. So your backups on-prem, they are not that huge. They are not consuming like a lot of space. So you can have your weekly, monthly, yearly on the cloud. You can do that today. But we really, again, we really recommend the copy mode when it's going to be available. If you have multiple locations, we tend to recommend backup copies to the other location. And then from there, again, just to tape as a third copy, or to the cloud as well as a third copy, just in case that you lose primary, secondary, and at least you have the third copy. Talking about that, if you have 2 sites or more than 2 sites and you have enough budget, we recommend it as well to use any of these Dedupe appliances, because again, their replication between them is really efficient itself, and also because you will be able to store a lot of backups and points in time on these 2 sites. And remember that we have our service providers as well. So if you have just a primary site, you can always send a copy into one of our service providers. And really leverage the Scaled Backup repository because it's a technology that we have for couple of years. So just combine different backup repositories. Please do not have 10 different backup repositories with different names and different retention on different backup jobs. That's too complex. It can be really simplified just by using Scaled Backup repository, and then you just combine all the backup repositories inside. And we again use the immutability when this will be released in V10. And I think the whole picture itself here is really take the data, move it to your primary backup location, and then after that just play as your company really requires the strict of the policies itself, and then leverage object storage when possible for your business. And I think with that, let's move back to Alex.
Thanks, Jorge. So we have about 5 minutes left, so there may be some things that unfortunately we can't cover. So I'm just going to give you a brief overview of how you might do things today in 9.5 and how that might change in version 10. So let's look at some backup data that we have in the system here. So this is quite an extreme example. It's not really, I wouldn't recommend using this for all of your data, but there are the odd time, and we've had customers where they might want hourly backups. Now you could achieve this with replication, but if you wanted hourly backups, this is just an example. We've got a backup job that does run hourly backups for this server. So we have 24, so we have a day's worth of restore points on the primary target. Obviously, we tried to extend that retention, then we're going to end up with quite a few number of restore points. And if we browse this, you'll notice that you can see the timestamp here. So we are creating a restore point every hour for this server because it's mission critical, and we want to minimize the data loss. But that's the primary backup. That is the short-term retention. What we're then doing is creating a backup copy. So if I now look at backup copy, we're doing a daily backup copy from that source job. So basically at 10 o'clock in the evening, we copy the last restore point that was created in that primary backup target, and we copy that to provide our dailies. But not only that, but we're also adding weeklies, monthlies and yearlies through GFS. So if I now look at the properties of this job, you'll notice that we have also got this going to a scale-out repository that has object storage copy and move enabled. So we have data on site and off site, but we're creating these weeklies and monthlies and yearlies. But you'll notice the timestamp is daily. So our first target for backup achieves our 24-hour hourly recovery window. Our secondary copy services our daily, weeklies, monthlies, yearlies, etc. And the object storage is where we send that much older data, those weeklies, monthlies and yearlies. So I just want to really reinforce that you don't have to have one single repository that's covering everything that you're trying to do in terms of retention. And by creating backup copies and using object storage, you can have data in multiple locations to recover from, and you're not just having one backup copy. And as always, if we integrate with your storage array in terms of VMware, then you have that added restore point in terms of the array snapshots that you can recover from or do test and dev with. Looking at a V10 job, well, if I actually go through this backup job here, because we're adding GFS to primary, it might slightly change the dynamics of how you might implement this in 2020. So if you look at storage here, what you'll notice is we still have the notion of normal restore points, but now we have the ability to keep weeklies, monthlies, yearlies on the primary backup job. If you don't have a secondary site to send backup copies to, and you don't want the hardware costs of having another device on the primary site or on the secondary site to create that secondary copy, well, you can simply extend your retention here, send it to a scale-out repository that has a copy enabled, and then object storage is going to provide your complete copy. As I showed you earlier, this V10 backup, if we look at this V10 backup here, we have this window. This is an agent-based backup, but we have that data locally as well as we have it out in object storage. So that object storage is our offsite, and it means that we don't have any. We have the costs of consumption and egress charges, etc. We are being clever with that with metadata in object storage. However, we don't have that cost of a secondary site. So hopefully that has been some benefit. We do apologise for the technical issues at the beginning of this session, and we've just about kept to the 1 hour that we were working towards. We do plan to do some sessions on Veeam 1, monitoring and analytics, our Veeam availability orchestrator, so advanced disaster recovery for our VMware customers, as well as a backup for Office 365. So hopefully you can join us for those future sessions, and hopefully this has been of benefit, and we look forward to seeing you next time.